Welcome to the next class in relativistic electrodynamics. Here in this second section, we will discuss the transformation equations of electromagnetic fields. That is how the fields are transforming from one inertial frame to the next inertial frame. There will be a short introduction. Then first we will discuss the transformation of electric field in which the magnetic field is zero. And then we will discuss the general transformation relation for electric and magnetic fields. The last is some mathematical steps required for the first two steps. Then first of all, in the last class we have learned that one observes electric force or electric field is another is magnetic field. In the last session we found that in the frame S it is the magnetic force, and in the frame S bar it is the electric force between an infinitely long straight current carrying wire and a point charge moving. So here we will derive the general transformation rules for electromagnetic fields among inertial frames. So there are some assumptions. First we will assume that the charge is invariant. That is, the charge of a particle is independent of its velocity. So the charge of a particle will be same with respect to all inertial frames of reference. The second assumption is we will assume that the transformation rules for the electromagnetic fields are same irrespective of their source. Irrespective of their source means, for example, we see that we know that electric fields can be generated either from the stationary charges, that is called electrostatic field, or moving charges, that is varying electric field, or electric field can be produced by variation of magnetic field. So field has two sources, charges and varying magnetic field. Here we will assume that the transformation relations for the electric field produced by the charges and field produced by varying magnetic fields are same. That is, there is no need to append extra information regarding their source. And this is a basic principle of the field theory in electromagnetism. First we consider a large parallel plate capacitor. Large means the separation between the plates are very small compared to the dimensions, that is length and breadth of the plates. So it has a uniform surface charge density plus or minus sigma 0 on both the plates, and it is at rest in a frame S0. So in a frame S0 the charge density is plus or minus sigma 0. Now in this frame, the electric field between the regions of the plates is E0 equal to sigma 0 by epsilon 0 y cap. So from the first diagram we see that there is an x direction, y direction and z direction. The plates are placed in the xz plane. So the electric field will be directed from the positive plate to the negative plate or along the y direction. So here E0 equal to sigma 0 by epsilon 0 y cap. Now the same capacitor is observed from another frame S moving to the right at speed V0. So we are considering the same capacitor from another frame S which is moving to along the x direction with respect to the first frame. So in the second frame S, the plates are moving to the left with the velocity V0. So here the charge density will be different because the charge is invariant, but the charge density depends on the dimensions. So the dimensions are length contracted here. So in the second frame S, the electric field E is sigma by epsilon 0 along the same y cap direction. Now what is the relation between sigma and sigma 0? That is the charge densities in first and second frame. The total charge on the plates are invariant, but the width is unchanged. Width means here the width is perpendicular to the x direction and length is along the x direction. So the second frame is moving along the x direction means the length will be contracted along the x direction and there will be no change in the width because it is perpendicular to the direction of motion. So the width is unchanged and the length is Lorentz contracted by a factor gamma 0 is equal to 1 by root of 1 minus v0 square by c square, where v0 is the velocity between s and s0. So in the S frame, that is in the second frame, in which the capacitor is moving in the backward direction, the surface charge density is increased by the same factor. So sigma will be equal to gamma 0 into sigma 0. As the length is contracted, the surface charge density will be increased. Thus, the electric field in the second frame is related to the field in the first frame by E perpendicular is equal to gamma 0, E0 perpendicular. Why it is called perpendicular means the electric field is perpendicular to the direction of motion, that is to the x direction. So the superscript perpendicular indicates that this rule is valid to components of electric field that are perpendicular to the direction of motion of the second frame. So E perpendicular equal to gamma 0 into E0 perpendicular. That is a transformation rule for the perpendicular component of electric field. That is the component of electric field perpendicular to the direction of motion between the two frames. Now to get the rule for parallel components, we place the capacitor plates perpendicular to the x direction. Now the electric field will be along the x direction. Here the plate separation d is decreasing, but there is no change in length and width because now both of them are perpendicular to the direction of motion. So the electric field, which depends on the surface charge density and epsilon 0, now surface charge density is not changing because length, then width and the total charge remains same. So here the parallel component of electric field, there will be no change in the electric field because the electric field is independent of small d. It is the same in both frames. So E parallel is equal to E0 parallel. E parallel is the parallel component of electric field in the S frame. E0 is the parallel component of electric field in the S0 frame. So the superscript parallel indicates that this rule is valid to components of E that are parallel to the direction of motion. So these are the two rules for the components of electric field. E perpendicular is equal to gamma 0 into E0 perpendicular, and E parallel is equal to E0 parallel. But these two equations are not the general, because the above two equations for the components of electric field, it relates only the electric field, and in which in the first case there was no magnetic field. So to get that general transformation rule, we have to start from a frame in which there should be both electric and magnetic fields. Here in S0, there was no magnetic field, only an electric field was there, and we have transformed the electric field successfully, but there was no magnetic field. Now we are going to start the treatment from a frame in which there is electric and magnetic fields. So we will start from the frame S itself. In the S frame means that is the second frame. In the S frame, the plates are moving in the backward direction, and there is an electric field sigma by epsilon 0. Here in this picture, it is a y component, Ey is equal to sigma by epsilon 0. In S frame, there are surface currents on the plates. Now the plates are moving in the backward direction, and it is charged plates. If sigma is the surface charge density, then the corresponding surface current density is sigma, that is surface charge density into velocity. That current density is along the x direction. If we consider the positive plate, that is the lower plate, the positive charge is moving in the backward direction. So it is producing a surface current density of minus sigma V0 x cap. It is minus sigma V0 because the positive charge is moving in the backward direction. And in the second case, in the upper plate, the minus sigma is moving in the negative direction. So it will produce a surface current density minus sigma V0 into minus x cap. So it becomes plus sigma V0 x cap. So there are two surface currents. The K plus, that is the surface current due to the positively charged plate, it is minus sigma V0 x cap. And K minus, the surface current due to the negatively charged plates, it is plus sigma V0 x cap. These two currents are producing a magnetic field in this frame. So in addition to the electric field, there are magnetic fields due to the surface currents. And by the right hand rule, the magnetic fields due to both these currents point in the negative z direction. Right hand rule means if we stretch our right hand such that the thumb is pointing along the direction of motion, and the remaining fingers will represent the direction of magnetic field. So it is magnitude is given by the Ampere's law. Bz is equal to minus mu 0 sigma V0. It is the z direction. It is along the negative z direction. So there is a magnetic field in the S frame. Now consider a third system, S bar, which is moving to the right with the velocity v relative to S frame, and the velocity is v bar relative to S0. So there are three frames. Our original frame S0, in which the capacitor was at rest. Then the second frame S, which is moving with a velocity V0 with respect to the first S0, and a third frame S bar, which is moving with a velocity V relative to the second frame, or with a velocity V relative to the S frame, and with a velocity V bar relative to the first frame S0. Now the fields in the S bar frame is E bar. It is equal to sigma bar by epsilon 0. Ey along the y direction, because the capacitor is placed along the y in this manner. So Ey bar is equal to sigma bar by epsilon 0, and Bz bar is equal to minus mu 0. The same treatment here. In S frame it is minus mu 0 sigma V0, but here it becomes minus mu 0 sigma bar V bar, because sigma bar is the surface charge density in the third S bar frame, and V bar is the velocity of the S bar frame with respect to the S0 frame. So here V bar is the velocity of S bar relative to S0. Now V bar is equal to, V bar is the velocity of S0 by using the relativistic addition of velocities. V bar is equal to V plus V0 by 1 plus VV0 by C square. And we will define a gamma bar is equal to 1 by root of 1 minus V bar square by C square. And sigma bar is related with sigma 0 by sigma bar is equal to gamma bar into sigma 0, because gamma bar is the 1 by root of 1 minus V bar square by C square, and V bar is the relative velocity of S bar with respect to S0. So sigma bar and sigma 0 are related by this expression, gamma bar sigma 0. It is similar to this expression, is sigma equal to gamma 0 sigma 0. Similarly here sigma bar is equal to gamma bar into sigma 0. Now we have to find the electric and magnetic fields E0, E bar and B bar in S bar frame in terms of E and B. For that we take Ey bar. It is equal to sigma bar by epsilon 0. That is equal to, sigma bar is equal to gamma bar into sigma 0 by epsilon 0. Now gamma bar into sigma 0 can be written as sigma 0 from the first expression. Sigma 0 is equal to sigma by gamma 0. So putting that here, sigma 0 is sigma by gamma 0. So it becomes gamma bar sigma by epsilon 0 gamma 0. That is gamma bar by gamma 0 into sigma by epsilon 0. Sigma by epsilon 0 is Ey. So Ey bar is related to Ey. Now we have to evaluate this bracket, that is gamma bar by gamma 0. Similarly, Bz bar, it is equal to minus mu 0 sigma bar V bar. That is equal to minus mu 0 sigma bar is converted into sigma 0 minus mu 0 gamma bar sigma 0 V bar. That is equal to minus mu 0 gamma bar into sigma 0 is sigma by gamma 0 V bar So that is equal to minus of gamma by gamma 0 mu 0 sigma v bar. Again we have to evaluate this expression. Now this expression gamma bar by gamma 0 is equal to gamma into 1 plus v0 by c square, where gamma is 1 by root of 1 minus v square by c square. The proof is shown in the last slide. You can see gamma bar by gamma 0. We proceed as follows. Gamma bar is equal to 1 by root of 1 minus v bar square by c square. Now take the denominator. 1 root of 1 minus v bar square by c square is 1 minus v bar is v plus v0 by 1 plus v0 by c square whole square into c square. So taking LCM, we get c square into 1 plus v0 c square whole square minus v plus v0 whole square by c square root of c square into 1 plus v0 c square whole square. When coming outside the root, it becomes this one, c into 1 plus v0 by c square. Now expanding inside the bracket by using a plus b whole square and by doing some mathematical steps which is shown here, we can see that it will be equal to c square minus v0 square into 1 minus v square by c square. So it can be written as 1 minus v0 square minus c square into 1 minus v square by c square by 1 plus v0 by c square. Now this one 1 root of 1 minus v square by c square, it is gamma, it is gamma, and 1 minus v0 square by, this is 1 by gamma, and this one it is 1 by gamma 0. So 1 by gamma 0 gamma into 1 plus this one. So gamma bar is equal to inverse of this one, that is gamma 0 gamma into this one. Okay, that is the proof. Now going back, so we can see this gamma bar by gamma 0 in our expression for Ey bar and Vz bar, it is equal to this one. Putting that value here, Ey bar is equal to gamma into 1 plus v0 by c square into sigma by epsilon 0. That is equal to gamma into sigma by epsilon 0 plus sigma v0 by c square epsilon 0. That is equal to gamma sigma by epsilon 0 is Ey, gamma Ey plus this one is c square epsilon 0. 1 by c square epsilon 0 is mu 0, because c square is equal to 1 by root of mu 0 epsilon 0. So it becomes mu 0. Then the remaining is sigma v0, sigma v0. So that is equal to Ey plus mu 0 sigma v0. That is equal to gamma into Ey minus Bz minus vBz. Mu 0 sigma v0 is Bz. That we have Bz is equal to minus mu 0 sigma v0. So putting that value here, we get gamma into Ey minus vBz. Similarly, Bz bar is equal to minus gamma bar by gamma 0, that is this expression, into mu 0 sigma v bar, that is equal to minus gamma into 1 plus v0 c square into mu 0 sigma v bar, that is equal to minus gamma into 1 plus v0 c square v0 by c square into mu 0 sigma v bar is converted into v plus v0 by 1 plus v0 by c square, that is equal to minus gamma into mu 0 this one into this one, that is mu 0 sigma v, because this mu 0 sigma v, this 1 plus v0 by c square and the denominator 1 plus v0 by c square gets cancelled. Remaining will be minus gamma into mu 0 sigma v plus mu 0 sigma v0. That is equal to minus gamma into mu 0 sigma, and I am writing here epsilon 0 by epsilon 0, then minus this mu 0 sigma v0 is minus Bz, so minus Bz. That is equal to minus gamma into this sigma by epsilon 0 is Ey, and mu 0 epsilon 0 is c square. So it is V by c square Ey minus Bz. So gamma into Bz minus V by c square Ey. That is the transformation for the Z component. That is, we have obtained the two transformations for the Y component of electric field and Z component of magnetic field. Ey is equal to gamma into Ey bar is equal to gamma into Ey minus Vbz, and Bz bar is equal to gamma into Bz minus V by c square Ey. This tells us how Ey and Bz transform. To do the transformation rules for Ez and By, we align the same capacitor parallel to the xy plane, that is in this manner. So the fields in S frame are, the electric field is along the Z direction, Ez is equal to sigma by epsilon 0, and the magnetic field is along the Y direction, it is mu 0 sigma V0. So the rest of the steps are identical. That is, everywhere we have to replace Ey by Ez and Bz by minus By, because Bz was minus mu 0 sigma V0. Now here By is plus mu 0 sigma V0. So replacing in this expression, in the last two expression, that is Ey by Ez and Bz by minus By, we get Ez bar is equal to gamma into Ez plus V By, and if By bar is equal to gamma into By, it becomes, there is a minus here, and here also there is a minus, and here it is already minus. So cancelling all the negatives, we get By bar is equal to gamma into By plus V by c square Ez. So these are the transformation rules for the Z and Y components of electric and magnetic fields. And the next, the X component of electric field. We have already seen that the parallel component of electric field, there will be no change. So it will be same in all frames. So Ex bar is equal to Ex is equal to Ex0. Then there is no magnetic field in the X direction here. So to get a magnetic field in the X direction, because by using this capacitor in this arrangement, we will not get a magnetic field in the X direction, because the movement is along the X direction. So we consider an infinitely long solenoid which is arranged along the X direction with the number of turns per unit length n. Now in the frame S, in the S frame, there is a current I, so consider the magnetic field within the coil is Bx is equal to mu 0 Ni, where mu 0 is the permeability and N is the number of turns per unit length, and I is the current through the solenoid. Now the same solenoid is observed in the S bar frame. S bar frame is moving to the right, so the solenoid will be moving to the left. As the solenoid is moving to the left, its length will be decreased. As length decreases, the number of turns per unit length will increase. So N increases. It becomes N bar. It is equal to gamma N. In the system S bar, on the other hand, the time dilates. So time dilation means I is equal to dq by dt. So the time dilation decreases the current in the S bar frame. So the current in S bar is given by I bar is equal to I by gamma. Thus the magnetic field in the S bar frame is Bx bar is equal to mu 0 N bar I bar, that is equal to mu 0 gamma N into I by gamma. Gamma and gamma gets cancelled, it becomes mu 0 Ni, that is equal to Bx. So similar to the electric field, the parallel component of magnetic field is also same in all frames of reference. So the complete transformation equations are Ex bar is equal to Ex, Ey bar is equal to gamma Ey minus Vbz, Ez bar is equal to gamma Ez plus Vby, Bx bar is Bx, By bar is gamma By plus V by c square Ez, and Bz bar is gamma Bz minus V by c square Ey. So these are the general transformation relations for the electromagnetic fields between two inertial frames of reference, and we have seen that the electromagnetic fields are transforming in a peculiar way so that the electric fields in one frame will be appearing as the magnetic field in the second frame, because By contains both By bar contains both By and Ez. Similarly, Ez bar contains both Ez and By. So the electric field will be produced in the second frame if there is a magnetic field in the first frame. But there are two special cases. The special case is, say if the magnetic field is 0 in S frame, then the magnetic field in the second frame By B bar, if in the S frame if it is 0, Ex Ey and Ez is Bx By and Bz is equal to 0. If Bx is equal to 0, Bx bar is equal to 0. So By bar, B is equal to By bar y cap plus Bz bar z cap. By bar is equal to gamma into V by C square into Ez into y cap. Then Bz bar is minus gamma V by C square Ey into z cap. So B is equal to V by C square, gamma Ez is Ez bar, and gamma Ey is Ey bar, Ez bar minus Ey bar. So that is equal to minus 1 by C square into V cross E. This can be written as minus V cross E, or B is equal to minus 1 by C square V cross E. Similarly, if E is equal to 0 in S frame, then E bar in S bar frame is V bar cross B bar. That is, if electric field or magnetic field is 0 at a point in one frame, then in any other frame, the fields at that point are simply related by the above two equations. If the electric or magnetic fields in one frame is 0, then at that point, the electric and magnetic fields in any other frame are simply related by using this expression.